To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
Hello my dear students, welcome to today's lesson. Today I am going to discuss with you all power and energy of electric appliances. This is the 10th lesson in your grade 11 science textbook. And as you all can see, it is a physics lesson. So look at these terms: power, energy, electric appliances. Now you are familiar with electricity. You all know what electricity is. We have learned static electricity, current electricity. So when current electricity is used in our day-to-day life, we call those devices that use current electricity as electric appliances. Now, if you look at your household, there are so many things. Now, you are listening to this lesson maybe through a computer. So, there you need to use electricity. It is a device that uses electricity. If it's a mobile phone, you charge your mobile phone. A ceiling fan, an electric cooker, an oven, an electric iron, lights, bulbs, all these use electricity. So, all these are electric appliances. Then, these electric appliances use electricity, they use electric energy and convert that into a different form of energy. So, while doing that, they have an energy input, they use energy and they give out energy output. And the rate at which that energy intake or energy consumption is carried out is what we call as the power of that particular electric appliance. Now, if you look at all these light bulbs, you are familiar with the wattage of bulbs. 13 watts, 20 watts, 40 watts. Even there are some appliances that use 100 watts, 1000 watts, 1500 watts. So, that is the power of that particular appliance. So, you are familiar with this because you use it at home in your day-to-day life. You have seen this. Now, in this lesson, we will try to understand and do calculations related to these quantities. Power and energy of electric appliances. In addition to that, we will try to understand how our household circuit works. The components of the household electric circuit. So, that is the introduction to this lesson. In the next slide, we will have a look at the contents of the lesson. Power and energy of electric appliances. So, power output of an electric appliance. So, like I said, they use electricity and they give out a type of energy. So, that means they have a power output. Then, electric energy consumed by electric appliances. Again, you are familiar with that concept. You all know some of the electric appliances use less electricity. Electricity consumption is less. Whereas there are some appliances that take up more electric energy. They use more electric energy. So, that is why we need to know the electric energy consumed by electric appliances. Then the third topic, efficiency of electric appliances and conserving power. Now, if you give a certain amount of electricity to a device, the device has resistance. You are familiar with that concept. So, because of that, they are not 100% efficient. So, we need to know the efficiency of electric appliances and how we can conserve power. That is how we can conserve electricity. Then, like I said, home electric circuits. Household electric circuits or home electric circuit or domestic electric circuit refers to the same thing. All the components or the main components present in your household circuit. You have seen some of those, like you know the main switch, trip switch, the bulbs, the plug sockets, those are all familiar to you. But we will be looking at all these components one by one and we will try to understand their function as well. Then the last topic is measuring electric energy in kilowatt hours. Now in your household there is an electricity meter where the number of units of electricity that you consume for a month is monitored. And that is usually measured in kilowatt hours. So that is what we will be discussing under the last topic. So those are the contents of this lesson. Now I'll move on to the next slide where we start the lesson. We use electric energy to do various jobs in our daily lives conveniently. On all these occasions, we convert electric energy into another form of energy to suit our requirements. So this is how the energy conversion takes place in an electric device. This energy conversion takes place in various electric appliances. The instruments used for these energy conversions are known as electric appliances. The main forms of energy conversions that take place in some electric appliances used in daily life are given in the figure. So in this, there are a few terms that you have to just keep in mind. Now we use electric energy. So here you can see electricity is a form of energy, and also there are converts electric energy into other forms of energy, and those devices are known as electric appliances. So those are things that you need to keep in mind. Now let's look at the examples given to us. The first one, a fluorescent light. Now you have seen these tube lights. We normally call them as tube lights. They are fluorescent tube lights because the shape is like a tube. Now you do get the LED tube lights also, but this is first example is the fluorescent light. Now in a fluorescent light, from the name you know, to get light. Electricity is converted to light energy. That is what we obtain as the output light. Then the television set, the TV. Obviously you use it to watch movies or programs, news. So there you watch and you hear the sound. So both light energy and sound energy. Then you have the radio set. Different types of radios are there. There you don't see anything, you only hear. So it is only the sound energy that comes as the output. Electric ovens for cooking purposes. So obviously when there is something to be cooked, you need heat. So electricity is converted to heat energy. Electric oven. Then we have the microwave oven. Similar thing. Electricity is converted to heat so that you can cook food. So the purpose is the same but different ways in which they function. The normal oven functions in one way, whereas the microwave oven functions in a different way. And you all are familiar with the different types of electromagnetic waves also. So we have discussed microwaves and microwave ovens. You all know the microwave ovens, the heat is produced within the food. So the way the food gets cooked is different. You all are familiar with that. Then there is the other type, induction cooker. Induction, by inducing something. By inducing a magnetic field, there is heat produced. So induction cookers. Again for cooking purpose, so electricity is converted to heat. Another device, electric heater, that also boiling water, cooking. So there they use a heating coil. You must be familiar with the heating coil. So there electricity to heat energy. Then we have the next one, electric motor. Motor, now in a fan, there is an electric motor. So the fan, the blades can rotate. It can be a ceiling fan, table fan, doesn't matter. There is electric motor used to pump water, water pumps. So there is a motor. So when you see a motor working, you all know it rotates. So when there is an object moving, the energy is kinetic energy. So in a motor, electric motor, electricity is converted to kinetic energy. So electricity can be converted to light, it can be converted to sound, or in television both light and sound. Then there are many electric appliances where electricity is converted to heat and also electricity is converted to kinetic energy. So electric motor, wherever you get the motor, there is electricity, electric energy converted to kinetic energy. But now when all these devices work, now say an electric motor works. After some time, if you touch the motor, what do you see? What do you know about it? I am sure you all know that it will be hot. Even a tube light or a television. But the modern ones, the amount of heat produced is less, but still there is a certain amount of heat produced. Even a normal filament bulb, you see when you touch it, you can feel it being hot. So usually when an electric appliance works, because of its resistance, there is a certain amount of electricity used against the resistance. Because of that, there is heat produced. So this is the main energy conversion that we expect to happen. But in addition to that, there is heat generated. You just need to keep that in mind. Is that clear, students? That is one point you have to remember. The other thing is you have to know that the electric appliances are not 100% efficient. There is efficiency, we will be discussing it, but they are not 100% efficient. And also, now these are instances where we look at the final type of energy that is produced. But there are devices where the energy undergoes changes. Electricity is converted to another form of energy. That again is converted to another form of energy. And that is what we will be using. So I'll be discussing that type of energy after this. So here in this slide we have extra knowledge. For extra knowledge, in some electric appliances, after the first energy conversion, another energy conversion also takes place and we use that energy. So for example, in a filament bulb, you all are familiar with filament bulbs, no students? Yes. In a filament bulb, you would have seen it, the bulb here, there will be a filament like that. That is also known as a tungsten bulb because usually the filament is tungsten. So here what happens is when you give electric energy, this particular filament gets heated up. Now tungsten has high resistance, so it becomes usually hot. So there it is heat energy that is produced first. Then due to that heat energy, you can see the filament glowing. Due to that, there is light emitted. So there the heat energy again gets converted to light energy. So then you get light energy. So here you can see as an example, in a filament bulb, electric energy is initially converted to heat, which increases the temperature of the filament, resulting in the emission of light. So there electric energy becomes heat energy, then it is converted to light energy. Another example. In fluorescent lights, electric energy is first converted into ultraviolet radiation, which is next converted into visible light. So in fluorescent bulbs or fluorescent lights, we can say, what is the energy conversion? Now there is electric energy, that is converted to UV radiation, and then the UV radiation is converted to light energy. So here students, when we say UV radiation, you all know UV radiation is an electromagnetic wave. So electromagnetic waves also have energy. So their electric energy is converted to UV radiation, then it is converted to light energy. So then there is something that you need to consider, students. Now if we consider some of the electrical appliances, now they have an internal resistance. Now you are familiar with internal resistance. Resistance is the factor that opposes the flow of current. So due to that resistance, the resistance of the electrical appliance, that is known as the internal resistance, in some of the appliances there is heat generated. Actually electricity is wasted as heat energy due to that internal resistance. So that is also something you have to remember, students. Now for example, in a electric motor, when the motor functions for some time, after some time if you touch the motor, you can feel that it will be hot. That is because some part of the electric energy will be converted to heat energy due to the internal resistance of the motor. But the main energy conversion that should take place is electric energy to kinetic energy, because you know the motor rotates. So like that, in some devices there is heat energy generated due to its internal resistance. That is also something you have to keep in mind. So if we write that as a note, in some electrical appliances, heat is generated due to internal resistance. So this is something you have to remember, students. Because of internal resistance, heat is generated. We will be discussing this with the efficiency of different electrical appliances. So if I quickly go back, now here you can see this is for extra knowledge, but you have to keep this in mind. In the previous slide, we looked at different electrical appliances where electricity is converted to other different forms of energy. It can be just one form of energy or more than one forms of energy. But in some of the appliances, there is a energy conversion occurring first. One energy conversion, let's say in an electric bulb or filament bulb, electric energy is converted to heat energy first. And thereafter only we get it as light energy. Now here the first step is heat energy. That is why after we use a filament bulb for some time, if you touch it, it will be hot, because there is heat energy generated and then it is converted to light energy. But in the fluorescent lights, if you look at it, fluorescent lights, electric energy is converted to UV radiation and then to light energy. And in some of the other electrical appliances, there is heat energy generated in addition to the main form of energy because of its internal resistance. So here of course, let's say like I said as an example, when the electrical motor works, there is electric energy being converted to kinetic energy. At the same time, heat energy is also generated because there is internal resistance. That is something you have to keep in mind, students. So I am sure you all can understand all these concepts. So with that, I will move on to the next slide. Power output of an electric appliance. So here, when we say power, normally what is power? Work done in a unit time. So here also it is the work done in a unit time. Work done by the electric appliance in a unit time. Or it is the energy, electric energy consumed in a unit time. That is what we call as power of an electric appliance. So here, work done in a unit time or the energy consumed in a unit time. That is what we call as power. Work done in a unit time or the energy consumed in a unit time. So even if it is an electric appliance, so here it is the work done by the electric energy, by electricity. Work done in a unit time or the energy consumed in a unit time. And the standard unit of power is watts. So here, just like in mechanical work, power is the rate of doing work in work done by electricity too. That is, if you look at this, you can understand what power is. Again, I have already explained, power is work done in a unit time or the energy consumed in a unit time. So here, if you look at it, there is the electrical source that provides the electricity, and here you can see I is current, and then you can see V, potential difference, that is the potential difference. So when a potential difference is applied across the electric appliance, here you can see electric appliance, and there is a current flowing from the electric appliance, there is an energy output. So here from the electrical source, you provide electricity to the appliance. From there, there is an energy output. So there is an energy conversion taking place. And during that time, the amount of electrical energy consumed in a unit time is known as power. And this power is equal to the voltage across the electric appliance multiplied by the current. Power is voltage into current. So an electric appliance operating with a potential difference V and drawing a current I will have the power equal to voltage into current. So I'll be repeating this again in the next slide also. So if we use symbols, power is given the symbol P. So potential difference V and current I. So that is the equation for power. You have to remember this. Power is voltage into current. So voltage is in volts, this is in amperes. Both together gives you the power in watts, W. Capital W, that is watts. Because it is the name of a scientist, you have to use the capital letter. SI unit of power is watts. You have to remember that. So there is a potential difference, there is current flowing, and the power is potential difference into current. Because power is the work done in a unit time or the electric energy consumed in a unit time. And the SI unit is watts. Like I said, students, I'll be repeating this again, how we derive the equation again also. So I will move on to the next slide. So therefore, the rate of energy consumption P, here you can see, therefore rate of energy consumption P by an electric appliance operated with a voltage of V and drawing a current I is given by the following equation. So power equals voltage into current. So therefore current. Therefore power P equals voltage into I, V into I. P equals V I. You all have to remember this equation. This is very important. Power equals voltage into current. So, P is equal to V into I. We will be using this equation to do calculations. And this has the unit watts. So, for example, if we supply 6 volts and the current drawn is 5 amperes, if you are to find the power of the appliance, power P equals VI. So, the potential difference across the device is 6 volts and the current drawn is 5 amperes. So, 6 into 5, 30 watts will be the power. Now, if you look at those labels in all the devices, either at the back of the device or with the conducting wire, the cable, they have a small label. You see all these. The voltage, the current consumption and the wattage. Wattage is the power of the electric appliance. So, you are familiar with this. Now, you all are trying to understand how to calculate them. So, power, voltage into current. P equals VI. This is how you do the calculation. With that, students, I'll move on to the next slide. Example 1. When a filament bulb is connected across a voltage difference of 12 volts, a current of 2 ampere flows through it. What is the power of the bulb? So, here power equals voltage into current. Now, I am writing the full equation so that you can remember it. You can use the symbols. P equals VI. So, what is the voltage? 12 volts and current 2 amperes. So, that is going to be 24 watts. That is the power of the bulb, 24 watts. Is that clear? You have to directly substitute the values and do the calculation. With that, students, I'll move on to the next slide. Example 2. Now, here you can see an electric oven operates under 230 volt power supply. If it has a power output of 2000 watts, find the current drawn when the oven is working. So, there. What are the quantities given to us? We know the power 2000 watts. Then we know the voltage 230 volts. We need to find current. Find the current drawn when the oven is working. So, what do? We know the equation. Power equals V into I. We need to find I. So, you can make the I as the subject. So, you rearrange power divided by voltage. You can do it that way or you can substitute and then do the calculation. Either way is fine. So, if we do this, power is given to you as 2000 watts divided by 230 volts. Now, you need to do the calculation. You can cancel off the zeros. So, we can take it as 200 divided by 23. So, it could be 8, 24, 16, 18. 200 minus 184, 6, 1, 16. So, we have to name the decimal 160. So, then 6, 18, 12, 13, 22. It's going to be 9. 27 to 18, 20. So it will keep on going, but you can divide it and get the value as 8.69. So here that is equal to 8.69 amperes. That is the current. So you can do it this way, or that is again the way you do it, the order. You can have power equals VI. You can substitute 2000 watts equals 230 volts into current. Then you can rearrange current equals 2000 divided by 230. Still you will get the same answer, 8.69 amperes. So the calculation is the same. The way you do the steps can vary. That is up to you all. You can rearrange first like this and substitute and calculate, or substitute then rearrange and calculate. That is fine. So this is to find the current drawn by the electrical appliance. I am sure you can understand that. So with that, students, we will move on to the next slide. In the heating coils, heating element of electric ovens, the energy consumed is converted only into heat. Now this is something I have discussed slightly, touched on. Now I told you all the devices, irrespective of their energy conversion, they do produce heat. Why? Because they have internal resistance. But in heating coils, immersion heaters, hot plates, rice cookers, in all these there are ovens, there are heating coils. Now in this, the conversion of electric energy is from electricity to heat. So only heat is produced. So here you can see in the heating coils, heating element of electric ovens, energy consumed is only converted into heat. So this is a diagram of a heating coil. If you remove a rice cooker also, below you can see a heating coil like that. A hot plate will have a heating coil like that. So this is the metal that acts as the coil. It is coil, so that, and it produces heat. That is why we call it heating coil. So here they choose a metal or an alloy that can produce lot of heat. You are familiar with one such substance. What is it? Nichrome, an alloy. Where you need to produce heat, you use nichrome. Why? Nichrome has high resistance. So you are familiar with that also. Right. So in some other appliances, part of the electric energy is converted into heat due to their internal resistance, while the remaining part is converted into other forms of energy. This is what I already discussed with you all. So in other devices, you have to remember this, in some other appliances, part of the electric energy is converted into heat due to their internal resistance. So a ceiling fan, a table fan, a radio, television, microwave, of course, heat is produced. So fluorescent light, in all these, the required energy conversion takes place. In addition to that, because of the internal resistance, there is heat produced by the particular electrical appliance. So that means they will not be 100% efficient. You have to remember that. Is that clear to you all? So in some, we use heating elements, we only produce heat. So there the resistance, the internal resistance is an advantage, because we need to produce heat. Even in irons, we produce heat. But in other appliances, part of the energy is converted into heat due to their internal resistance. There, of course, it is not 100% efficient. You have to remember that. So with that, students, I'll move on to the next slide. Electric energy consumed by electric appliances. Power is the rate of consumption of energy, or the energy consumed in a unit time by an electric appliance. So here power is the rate of consumption of electric energy or the energy consumed in a unit time by an electric appliance. Therefore, the total energy consumed by an electric appliance depends on the time duration that it operates. So, there is a power of a particular appliance. If it works for say 1 minute, a certain amount of electric energy is consumed. If it works for 1 hour, then the time duration is more. Then it will consume more electric energy. So that means electric appliance depends on the power of the electric appliance and the time duration of the electric appliance being used. So it depends on power and time. So therefore, if the energy consumed during a unit time interval is P, the total amount of electric energy consumed in a time T is given by PT. So, if the total energy consumed is E, energy consumed is equal to power multiplied by time. Power is the electric energy consumed in a unit time, that multiplied by the time for which the electric appliance is operated will give you the energy consumed by the electric appliance. So, if we write that as E, energy consumed, power is P, into time is T. E equals P into T. So, here what is the unit for energy? Energy equals power into time. Power is in watts, time is in seconds. But you all know normally watts is equal to joule second. We have discussed work, power and energy before in the previous grade. So, here joule per second into second. So, the second and seconds cancel off, you get the unit joules. Always energy is measured in the unit joules. So, SI unit of energy, SI unit, you have to remember energy, that is electric energy or whatever energy, it is in joules. And power is in watts. You all have to remember these. So, if we look at it, electric energy consumed by electric appliances, power is the rate of consumption of energy or the energy consumed in a unit time by an electric appliance. Therefore, the total energy consumed by an electric appliance depends on the time duration that it operates. So, it depends on both power and time duration. So, if the energy consumed during a unit time interval is P, then the total amount of electric energy consumed in a time T is P into T. If the total energy consumed is E, then you get this equation. Energy consumed equals power into time. So, that is E equals P into T. So, here you can see this energy, power into time. Watts into seconds. Watts is joule per second into second. So, you get the unit as joules for energy. Anyway, you all know the unit of energy is joules. Whether it's kinetic energy, potential energy, electric energy, all the types of energy, the unit is joules, standard unit. So, energy in joules and power in watts. With that, students, we'll move on to the next slide. Since P equals VI, we have already discussed that power equals voltage into current, that is P equals VI, and energy power into time, that is E equals P into T. So in this, if you substitute, what happens? Energy E is equal to, instead of power, we can substitute voltage into current into time. So you get this equation. E equals VIT. Energy equals voltage into current into time. Is that clear to you all? So if there is the equation where you know the power and the time the electric appliance was operated, you use the first equation. E equals PI. But instead, if you have the values of voltage and current and time, then you use the second equation, E equals VIT. So both can be used to calculate the energy consumption of an electric appliance. Is that clear to you all, students? So with that, I'll move on to the next slide where we do a calculation. Example 1. The power of the headlight of a motor car is 50 watts. You know the power, 50 watts. Find the energy consumed when this lamp is operated for time 1.5 hours. Now 1.5 hours you can't use it directly. Always you have to have the time in seconds. So 1.5 hours, 1.5 hours. If you want to convert it to seconds, what do? 1 hour, 60 minutes. 1 minute, 60 seconds. So you need to multiply this by 60 into 60. So then of course you will get the value 1.5 into 60, you get 90. Then 90 again into 60, 5,400. So 5,400 seconds. Okay. So then if we are to do the calculation, 5,400 seconds. Power 50 watts. So we need to calculate the energy. Energy equals P into T. Power 50 watts into time 5,400 seconds. So that is going to be, you will get the value as 0, 0, 0. There are 3 zeros. Then 5 into 4, 22. 5 into 5, 25, 27. 270,000 joules. Or else you can write it as 270 kilojoules of electric energy is consumed. 270,000 joules. Is that okay, students? So you know the power of the appliance, you know the time, but you have to remember always the time has to be in seconds. So if you are given in hours, you multiply by 60 so that you get it in minutes, and then again you multiply by 60 to get it in seconds. So the hours have to be multiplied by 60 into 60, or some of you all do it as hours into 3,600, because 60 into 60, 3,600. That is also correct. So if you want to calculate another way, some of you all remember it that way. Hours into 3,600 equals seconds. That is also fine. Whatever is convenient for you all, but you have to do the conversion. time has to be in seconds. Then you use the equation here. You use the equation there. E power into time is energy. So power 50 watts, time 5400 seconds. When you multiply, you get it as 270,000 joules or 270 kilojoules. Is that clear, students? So then I'll move on to the next slide where we look at another example. Example 2. A 6-volt bicycle electric bulb draws a current of 0.6 amperes. So again, you get the values. A 6-volt bicycle bulb draws a current of 0.6 amperes. What is the power consumed in lighting this bulb for 5 minutes? So again 5 minutes. So then you know the voltage 6 volts, I current 0.6 amperes and time 5 minutes. So we have to convert these to seconds. Minutes to seconds, you multiply by 60. So that will be 5 into 60 seconds, 300 seconds. 5 into 6, 60, so 300 seconds. Then, you know the potential difference, you know the current, you know the time. What is the equation we use? E equals VIT. So here we use energy equals VIT. Voltage 6 volts, current 0.6 amperes into time 300 seconds. So there, if you get it, 0.6 into 300, 6 into there 180. So then again 6 into 180, 1080 joules. That is the energy consumption of this particular bicycle electric bulb. Is that clear, students? So there are two equations. Energy equals power into time, or energy equals VIT, voltage current into time. Depending on the data given to you, you have to do the calculation. So I am sure you all can understand this. So with this, students, I am going to end this chapter, and when I start the next chapter, I will discuss the efficiency of different electrical appliances. And thereafter, we will be discussing the household electric circuits and its components.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.